This is Josh White from JW Math Tutoring. In today's video, I'm going to go over 10 problems from the June 2025 Digital SAT Math Exam. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I start going through these 10 problems from the June 2025 SAT math section, I want to highlight and mention a couple things. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, these problems are basically self-reported, gathered from various places, Reddit, Discord, and so on. So I've tried to make these, I think, as realistic as possible, but there might be some details that I am missing that you might have seen if you got a specific question when you took the June test. And related to that, some of the questions might have been multiple choice, but I'm going to do them as free response. So please keep in mind that there might be other ways to solve these problems if they were a multiple choice question as compared to just being done as a free response. Okay. Third thing, there'll be 4 total videos, basically 4 total worksheets as part of these June 2025 problems. So please check out the other videos, part 2 and part 3 and part 4 once those are posted. And of course, if you have any comments, alternate solution methods, so on, please feel free to leave them in the video below, in the comment section below. And lastly, the link to these problems will be posted in the description of the video and in the pinned comment as well, as in addition to the links to the other videos, parts 2 and 3 and 4. Links to those videos, once they're up, will be posted in the pinned comment. All right, so with all that being said, let's go ahead and get started here. Problem number 1. Here we have a circle, and you're given 2 diameters of this circle. So let's basically draw a basic circle right here. Okay, here's our center. Let's say this is diameter AC, and then the other one we have is BD. Okay, so let's say this is B and this is D. All right, now total circumference is equal to 96 pi. AB is 3 times the length of AD. So AB right here is 3 times the length of AD. So what I'm going to do is I'm going to let AD right here, just pick a different color, be equal to X. And then AB, which is 3 times that, I'm going to say is equal to 3x. Now, the corresponding arcs, kind of that are across from the ones that I've labeled x and 3x, so in other words, BC, kind of you could say it's across from AD, is going to have the same length as AD, basically because of the fact that we have 2 diameters intersecting inside the circle. And the same thing is going to be true down here with AB and CD. So now what you can do is you can just go ahead and add everything up. 3x plus x plus 3x plus x, and you can set that equal to 96 pi. Let's see, 3, 6, 7, 8. 8x equals 96 pi. Divide by 8. X equals 12 pi. So they want to know the length of arc BC. That is just one of the smaller ones, which is just equal to x. So the correct answer for this problem is just going to be 12 pi. If the question had asked for the length of one of the longer arcs, of course, then you would just take the 12 pi, multiply it by 3, and your answer would be 36 pi. Next question, number 2. This is a common one that has appeared recently. You're given some expression with both x and y, 2 variables, and you're asked which of the following is a factor of it. So the way to solve this is to note that there's a common factor here of x minus 3. So you can pull that out as a GCF. And then what you're left with is just y squared minus 25 and then x minus 3 squared. Then the inside is basically going to, inside the bracket, it's going to be factored as a difference of squares. You're going to have y plus 5x minus 3. Notice it's in parentheses like this. and then y minus 5 parentheses x minus 3. And of course, we still have the x minus 3 out front. Now, for these, you're going to have to distribute. So y plus 5x minus 15, y minus 5x plus 15. Okay, so now we can go ahead and basically just look at the three factors that we have and see which one is one of the answer choices. All right, so we don't see x minus 3 anywhere. Then we have plus 5x minus 15 minus 5x plus 15. Okay, so it looks like it's going to be right here, answer choice C, y minus 5x plus 15. That's our correct answer. I don't know of any way to do this entirely in Desmos because of the x and the y. If you do know of a method that you can use to determine which one of these is a factor in Desmos, feel free to post it below. Definitely take a look at it. All right, next up we have question number 3, which is a percentages question. So first I will show you how to do this in by hand, and then I'll show you how to do the entire thing in Desmos. So x is 40% greater than y. So that means basically you could say x is like taking y and adding 40% of y. However, the shortcut approach, shortcut method, is basically that x is going to be 1.4 times y. J is 40% greater than x, so you can set up a similar thing where j is equal to 1.4 times x. K is p% less than y. So for this one, really what you're saying is like you have y, you take away p% of y. So this now can be factored. Essentially, you just pull the y out front, and I'm going to turn it into y times 1 minus p. Okay, so now we go to the equation. J plus k equals x plus y. All right, what's the value of p? So we have 4 different letters here. How are we going to, basically find the value of p? So essentially what we're going to do is we're going to substitute in for everything, and we're going to get an entire equation in terms of y, and you're going to see the y's are going to drop out, and then you'll be left with a value for p. So for j, you put in 1.4x. For k, you put in the y times 1 minus p. For x, you put in 1.4y, and for y, we just leave it alone. So now we have basically 3 terms that we've gotten in terms of y, and we have one that's still in terms of x. So now what we have to do is, let's see here, just substitute in for x what it's equal to. So in other words, take x and put in another 1.4y. So now what we end up with is make sure I get this correct, 1.96y, that's 1.4 times 1.4, plus y times 1 minus p. I'm not going to distribute it, and you'll see why in a second. And then over here, 2.4y, you can just combine those, like terms. All right, so now, at this point, you could technically divide everything by a y, or really the way that I did it is I brought this 1.96 over to the other side, subtracted it. And essentially that gave me y times 1 minus p equals 0.44y. And now the y's canceled out. I got 1 minus p equal to 0.44. And then if you want to solve this, you could just do minus 1, negative p equals negative 0.56. Divide by negative 1 to flip the signs. P equals 0.56. So notice this is in terms of a decimal, but the actual number in here, because they're saying p%, the actual answer is going to be 56, not 0.56, because it is 56 k is 56% less than y. It's not 0.56% less than y. So the correct answer for this one is going to be D. Again, this is how you could do it, do the entire problem by hand. Now let's take a look at the Desmos solution. So let's see here. I started with, just make sure, I think I started with y equal to 100 because then x was, again, 40% more than y. And then we knew that j is equal to 1.4 times x. All right, so now what I did is I set up an equation. Sorry, not equation, regression statement, where I said j plus. Now the thing is, I didn't actually, for k, you'll see I substituted in minus py. Okay, so now I think what I have to do is change this to y1, make this y1. Yes, I need the numbers to actually be showing. So change this to x1. There we go. Need to use x1 and y1, not just x and y. Otherwise, this is going to give graphs. It's not going to give actual numerical values. And then in my regression statement, let's change this y1. Okay, and now you can see right here. Basically, I took the j plus k tilde x plus y, except I had to replace k with what it's equal to in terms of y, which is the y1 minus py. And now it solves this statement, this equation regression statement, for p, and you get 0.56. But you do have to remember that because it's expressed, the answer is expressed as a percentage, not as its decimal equivalent. You know, the answer is going to be 56, not 0.56. But this is how you could do the entire problem in Desmos. All right, let's take a look at the top of the next page. Problem number 4, sum of solutions problem, and you have a constant. I'll show you first how to do this by hand, then we'll take a look at the Desmos solution. So the way to solve this by hand is basically to do the following. Bring everything over to one side. So I'm going to move everything over to the left. So in other words, I get t minus 81 squared minus 3t times t minus 81 plus k times t minus 81. So everything's equal to 0. Then what I'm going to do is I'm going to factor out a common factor of t minus 81. That's going to leave me with t minus 81, because it's squared initially, so there's still one left. And then this cancels out, minus 3t. This cancels out, plus k. All right, so now, basically, we have two solutions. Solution number 1 is just t equals 81 from this first parentheses. Solution number 2 comes from this, gigantic second parentheses, or what's in the entire expression inside the bracket. So we know that the sum of solutions is 83. So 81 plus 2 equals 83. That means this entire solution inside the bracket right here, okay, this entire thing must be equal to 2. So we can go ahead and we can basically do the following. Let's first make it negative 2t minus 81 plus k. All right. So now, actually, sorry, we're going to use that 2 in a second. What we're going to do is we're going to first, solve this for t, and then in terms of k, and then after we do that is where the 2 will come into play. So we get negative 2t equals, I'm going to add 81 to the right, I'm going to subtract k. Then I'm going to divide by negative 2. So t is equal to, now I'm going to flip the signs here. So this is negative and negative. I'm going to put this first because it becomes positive, and I'm going to put this second. So k minus 81 over 2. So solution number 1 is this. Solution number 2 is this. Together, they add up to 83. Like I said, That means the second solution, this one right here, has to equal 2 because 81 plus 2 equals 83. Therefore, you can now say k minus 81 over 2 equals 2. Solve this for k. 2 times 2 is 4. Add 81 to both sides. K equals 85. Again, that's the approach to do this by hand. What I did is I got everything equal to 0. I factored out a t minus 81 common factor. I then solved for the two solutions, one of which was 81, the other of which is this expression that has a k in it. And then I used the fact that the sum of the solutions is 83 to determine that this second solution had to equal to number 2. And I solved for the value of k based on that fact. All right, let's see how you could do this in Desmos. All right, so basically what we need to do here is I need to, again, pull everything over to one side. Really the same first step that I did solving it by hand. Okay, then I'm going to do regression, and I'm going to regress this to its factored or intercept form. So I'm just going to do, basically, since this is a quadratic, I know it's going to have two roots or two solutions. I'm going to just call them A and B. Okay? And then also I know that my two roots or my two solutions, the sum of them is equal to 83. However, what you have to do is you have to get this equation in terms of one variable or one constant alone. So I need it to be A equals 83 minus B, or you could also do B equals 83 minus A. If you want to know more about how to solve a sum of solutions problem using this method, check out my ultimate Desmos guide to digital SAT math. Is in, I believe, part 9, and I go through and explain how to do it and look at some example problems. All right, so now we can just define T as a list. All right, and it should be giving us a value for k, but it's not giving us a value for k. Why is the regression not working? Oh, I put an x1 here. It's supposed to be t, not x1. That's the whole reason for the error. There we go. Sorry, everything's supposed to be in terms of t. I mean, you could do it in terms of x1, but I'm just doing t to keep it consistent with the problem. All right, so once I enter my list for t, there is the value for k. It is 85. Okay? And basically, that's it. That's all you have to do in Desmos to solve this problem, and we can move on to the next one. All right, let's look at question number 5 here. So this is actually a repeat question. This is one that has come up before. Basically, you have this expression, fourth degree polynomial. It can be factored two different ways, and like one set of the factors are positive or integers, the other set are non-integers, and then you want to add together, you know, the values of A and C. So there's two different ways to show this. I like to do this basically entirely in Desmos. I don't really know of an easy way to do this by hand. I mean, the integer one is easy. It's going to be 3x squared and 2x squared. And you could go through, you know, the factors of 55, and basically it's going to be 11 and 5. It's going to work out like this because this is 22 and this is 15. They add up to 37. Okay, so basically A is 11, C is 5. That's easy. The non-integer part is what's, you know, difficult. So there's two approaches you can take in Desmos. I will show first the method, I guess the method that I actually prefer, and then I'll show you what might be a quicker or easier method using regression after that. So the way I like to think about this is, okay, you think about factoring, right? You do FOIL. So the outer and the inner, these things together will, you multiply them out, add up the two terms, and you're looking to get 37. So like, you know, 2a plus 3b equals 37. And then also you need the two terms here, like the a times b, to equal 55. You know, the last two terms multiplied equal 55. So you set up a system of equations using that, except I'm going to use x and y. And then you just look for the solutions. Those are going to be your a and your b and your c and your d. Okay, so here's the graph. maybe just zoom in a little bit. So here's one solution, here's one solution. Let's just like export these. Okay, so we have the 11 and the 5. That's the A. And by the way, and I wrote that as C. That's wrong. That should be, that's B, not C. Sorry, this should be B here, A and B. And then C and D are the other two intersection points. The 7.5 and the 7 1/3. 7.5 and the 7.333, repeating, which is basically just going to be, 22 over 7. Okay, so A plus C, 11 plus 7.5, 18.5. That's your correct answer. That's what you would type in. That's what you would report. You could also technically do it as 37 over 2 as well. So either 18 over 5 or 37 over 2. Either of those would be accepted as correct. So that's one method to do it. Now I'll show a second alternate method you can use. So you can do regression. The problem is you have to do a little trick. So, okay, we're going to do the original statement. Okay, then we're going to regress to 3x1 squared plus a, 2x1 squared plus b. Okay, and then we'll define x1 as our list. Let's see if the random function will work here. Yes, we get a is 11, b is 5. Okay. So now what you do is you basically, you do the regression again, but you change the order of the parentheses. You still keep it as x1, but you put the 2x1 plus, in this case, d first. What's going on here? And then the 3x1 plus c would be second. Get rid of all this. Okay, so notice here, I do the regression again, but I flipped the order of the parentheses. That causes it to find the second solution, basically the non-integer solution. Right here, see it's 7 1/3, blah, blah. So now, what's the value of a plus c? A plus c, 18.5, there's your answer. So this is the way you could do it. I don't know why flipping the order of the parentheses, but keeping the same, keeping it as x1 and everything causes it to find the second solution, but it does, and this is an alternate way you could do it. Third way you could do it as well, following the same approach, is you could take the original thing here. You could get your first answer. So let's just say, whatever, 11. Just write that down. And then you could put in a qualifier or constraint, basically. So like, let's make a less than 10. See, if you do that, that'll force it to get the second answer. And then here you'd have to remember technically that a is really the c value. So you could then get the 7.5 to add to it. So that's an alternate way if you don't want to like copy or retype the whole thing. You can put in a constraint, but you technically wouldn't know which way to go to make a like less than the 11 that it originally found or greater than it. So you might have to do some testing, on that to see. All right, let's look at question number 6 here, bottom of the page. This is one that is, it's basically a very, very similar problem to one of the questions on the Blue Book test, except one wrinkle they introduced is that they added a cost, that basically a gallon of paint costs $23. So all that does is that just basically puts the 23 or whatever it was in your problem out front here. Like that doesn't change, this part of the problem, which is really, that's all the only thing that's different. The 23 is, the same between each of them. So a gallon of paint covers 300 square feet. And you want to know what's the cost to paint the deck twice. So here's how I would look at this. 1 gallon covers 300 square feet. Okay, and I would basically use unit conversions. So the deck has d square feet. So multiply by that, the units cancel out. That means technically to paint the deck one time, it would be d over 300 square feet. However, he's painting the deck twice, so you have to take this and multiply it by 2. So that gives you 2D over 300, or in other words, D over 150. That's the number of gallons needed, and then of course you multiply by $23 per gallon. But the correct answer for this one is going to be letter A, right here. Now, you could also do this by picking numbers as well. So, here is basically how I would do that. I'm going to let D equal 300, okay? So in other words, this deck has a total area of 300 square feet. 1 gallon will cover 300 square feet, right? He wants to paint it so 1 gallon will cover the deck once. If he wants to paint it twice, how many gallons is he going to need? Well, he's going to need 2 gallons, right? Because it's 600 square feet that you're covering, and 1 gallon covers 300 square feet. So he needs 2 gallons of paint. Just ignore the 23 part, because again, that's the same. And then for the cost, I mean, you multiply by 23, but that's the same in all the answers. So now you go through and you plug in the value of D of 300 for D, and you see, for these 4 answer choices, which one of these, just for ignoring the 23 for right now, for the rest of it, which one gives you 2? And it's going to be A again. 300 divided by 150 is 2. 300 over 300 is 1. This is some gigantic number. It's wrong. This is an even larger number. It's wrong. So again, you could pick a value for D, and then you could calculate the total number of gallons needed, and then you could plug that into the answer choices to see which one it matches it. All right, let's look at the top of the next page, number 7. Here we have a unit conversion question that seemed to be fairly popular. Basically, you had the speed of an object changing at a rate of 1,540 meters per hour per second. I want to know this rate of change in feet per second per second. So you have to do 2 conversions here. You have to convert hours to seconds. So you could do 1 hour, 3,600 seconds if you know that. If you don't know that, you do 1 hour is 60 minutes, and then you do times 60. 1 minute is 60 seconds. So either way, you're going to end up dividing by 3,600 overall. You have 2 60s being multiplied on the bottom. That cancels out the hours, and now you have per second per second. But you have to convert the meters to feet. So now we're going to use the conversion. 1 meter, 3.281 feet. So now the meters cancel out, and now we're going to have feet per second per second. So this we can just go to Desmos and just type it in. (1540) times 3.28 divided by 3,600, 1.403111. I'm not sure why I have 1.404 as the answer there. It should be 1.403. So I'll correct that. I'll fix that on the answer sheet. But really the way it would say this on the test, it would say which of the following is closest to the rate of change in feet per second per second. Because again, this unit conversion is just an approximation. It's not exact, but in any case, it's going to be B. That's the one that's closest to it when you go ahead and work it out. All right, let's talk about question number 8 here. This is basically a linear interpretation word problem. So you have this boat. It travels up a river for some period of time at a speed of 12 miles per hour. Then it turns around and travels down the river at a faster speed, basically 4 miles per hour faster, so essentially 16 miles per hour for y hours. And then it ends up 10 miles more down the river. So basically, like this distance right here is basically 10 is what they're saying. It goes 10 miles past its original starting point. Which equation represents this situation? So here's the thing. The x and y, those represent times, which are always positive. Time is never negative. So if you go to plug in values here, just like for x or y, all right, so like just whatever, just if you just pick whatever numbers, it doesn't really matter. But if you plug in positive numbers, say like, look at for A, 12 times 1 plus 16 times 1. So it goes 1 hour each direction. I mean, that doesn't make sense with the numbers in the problem, but just for this type of analysis. Notice you're going to get like 12 plus 16, which is 28, meaning the numbers are added together. It's not going to equal 10 because you're adding these two distances together. So the two things being positive is not going to be a possible correct answer to the solution. Now, the question is, okay, if it's going to be subtracted like this, where it's 12x minus 16y, is the answer going to be positive or negative? So, think about it. The total distance traveled here from the start of going upstream is like this length. Then it travels, the same distance, but also going an extra 10 miles more downstream. So if you take this distance and you subtract from it this distance, you take a smaller number and you subtract from it a larger number, the answer should be negative. Correct answer is going to be D for this one. This is some positive number. This is a positive number, total distance traveled going downstream. When you find the difference between them, it's going to be negative 10 because you're doing a smaller positive minus a larger positive because it traveled a larger distance. It traveled 10 more miles basically going downstream. So that's why it's going to be equal to negative 10. All right, let's look at question number 9, the one that deals with conditional probability here. So if you select a tree from this table, what's the probability that it's from area A given that it's a redwood tree? So this means we're technically only looking at the total population of redwood trees. So we have 40 total trees to choose from. And the probabilities from area A is just going to be, well, 24 out of 40. This just reduces to 3 over 5. You could also put it as a decimal 0.6. So these are going to be your correct answers. 24 over 40 should be accepted as well, even though it's not reduced. But this is the answer. Again, basically, given that's a redwood tree means we're only looking at the top row. And then the probability that's from A, well, there's 24 in area A that are redwood trees. So just 24 out of 40, and that's the answer. All right, let's look at question number 10. This one deals with similar triangles. This is actually a repeat question. This one has been featured on the SAT before. Basically, you have an isosceles triangle. Okay, so we have A at the top here, and we have B and C down here because we know AB and AC are congruent. Okay, this one's kind of a pain just because you have to draw the entire thing out. Point D is on side BC such that BD, okay, so this is 2/11ths of BC. So that means like if this whole thing is X, this is 2/11ths of X. And that technically would also make this 9/11ths of X because together 2 over 11 plus whatever has to add up to one whole unit. But we can really just ignore the X. That part's irrelevant. We can really just kind of put these in a ratio of 2 9/11ths, 2 9/11ths. All right, point E is on AB somewhere here. Point F is on AC. So this is F, sorry, this is E, such that angles BED, okay, so this angle and DFC are congruent. So these two angles are congruent. The value of EB is 6. All right, what is the value of FC? So here's what's going on here. These two triangles are going to be similar, and the reason is going to be from the angle-angle similarity postulate. So you have one pair of angles given as congruent right here. You have this pair of angles also congruent because it's an isosceles triangle. So since AB is equal, the length of AB is equal to the length of AC, therefore the angles across from those angles will be congruent as well, basically the two base angles. So now you have two similar triangles, and essentially what's going to happen is you have BD to DC, like this to this. That ratio is going to be equal to the ratio of BE, or EB, either way, to FC. So now with these, technically, even though it's 2/11 and 9/11, you can actually simplify them or just change them into two. The Ravel ratio of one side to the other is really going to be 2 to 9. So you could put 2/11 over 9/11, but the 11s will cancel out, and it's really just going to be 2 to 9 for BD to DC. And then BE is going to be 6. FC is the unknown. Now you can just cross multiply to solve this, or you could just notice it's just times 3. So x is going to be 27. But if you cross multiply, you get 2x equals 54, x equals 27. So that's the correct answer right here. All right, so I hope you enjoyed this first set of problems from the June 2025 Digital SAT Math exam. If you have any questions or comments, again, alternate solution methods, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And as I mentioned, be sure to check out videos and worksheets numbers 2, 3, and 4 once those are all posted. And lastly, if you're looking to improve your Desmos skills, please do check out my Ultimate Desmos Guide to Digital SAT Math. We're up to basically now almost 4 hours of tips and tricks and almost 60 practice problems to help you ace the Digital SAT Math section.